Good morning everyone, and welcome to today's worked exam answer video. Now, as I alluded to yesterday, I'm back having a look at the bottom part of this, well, they're not the same question, but the question on the bottom half of this piece of paper. So yesterday I had a look at the top part, which was a reaction of halide ions with sulfuric acid. Very different type of question here. Today we're having a think about elements on the periodic table and how we can classify them into different blocks of the periodic table. So hopefully in atomic structure at the very start of year 12, certainly again when you then did periodicity at some point in year 12, you will have had a look at how the periodic table can be split into 4 different blocks. We've got the S block, the P block, the D block and the F block. What we are asked to do for this question is explain why certain elements in the periodic table are classified as P block elements. So we need to know which are the P block elements and why they belong to the P block, or why those elements have been put into something called the P block, and then illustrate our answer with an example of a P block element. We can choose any we like and give its electron configuration. So probably helpful just for me to start by getting my periodic table, which just about see most of. So in terms of where the blocks are, group 1 and group 2, that's our S block. This rectangular bit in the middle, which you've probably historically called the transition metals, that really should be called the D block, because there are 2 examples in there, scandium and zinc, that aren't actually transition metals, but they are D block elements. So the rectangular bit in the middle is our D block. The 2 lines at the bottom, the lanthanides and the actinides, they are the F block. And with the exception of being asked in a multiple choice question which of these is an F block element, and picking out whichever example falls in there, don't need to worry anything about those elements at all. And then most importantly for our question, we've got the P block, which is groups 3 through to 0. Now, in terms of why these elements are our P block elements, comes down to their electron configurations. So I could pick any element in here and give an electron configuration where the outer electrons will be in a p orbital in a p sublevel. Now, in terms of writing those electron configurations, you only need to be able to do up to krypton. So if I choose a couple of examples prior to krypton, so carbon would have an electron configuration of 1s2 and then 2s2 for my lithium and my beryllium, and then 2p2. So the outer electrons of carbon are in 2p orbitals within the p sublevel, and that's why carbon falls into the P block. Sulfur would be 1s2, 2s2, 2p6, 3s2, 3p, 1, 2, 3, 4. So it's 4 outer electrons are in p orbitals within the 3p sublevel. So again, that makes sulfur a P block element. Could do the same for any of these 6 here. So krypton, to do a noble gas, would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. All of its outer electrons are in the 4p orbitals of the 4p sublevel. And that would apply for all of these elements as well. We just don't need to do their configurations. So yeah, anything that's in group 3 will have 1 electron in 1p orbital. In group 4, there will be 2 electrons, which will be singly occupying 2 of the orbitals. Everything in group 5 will have 3p electrons, each singly occupying 1 of the p orbitals. Group 6, we will then get pairing in 1 orbital, single, single. Group 7, we will have 2 pairs and then a single. And then in group 0, we'll have pair, pair, pair in our p orbitals. So they all fall in the P block for that reason. So I can pick any of those examples to illustrate that point in my answer to question 13. So explain why certain elements in the periodic table are classified as P block elements. Illustrate your answer with an example of a P block element and give its electronic configuration. So I'm actually going to do the second bit first to help me then explain the first part. It says I can illustrate my answer with an example of a P block element, so I can do any. So obviously it would be a bit silly to pick something like krypton when we can pick something a lot higher up and do a bit less work. So I might do nitrogen, just to do a different one from what I've just said. So nitrogen would be a P block element, and nitrogen's electron configuration would be 1s2, 2s2, 2p3. 1, 2, 3. So that's its electron configuration. I've given an example, nitrogen, and then I can say nitrogen is a P block element because its outer electrons reside in p orbitals within the 2p sublevel. All p block elements will be the same, as in all P block elements will have their outer electrons in p orbitals within a p sublevel. And yes, that is the same for the other blocks as well. So if we have a look at sodium, which is in group 1, which is part of the S block here, sodium's configuration would be 1s2, 2s2, 2p6, 3s1. So it's in group 1 because it's got 1 electron in that main energy level, which is in the first of the sublevels, the S. It's only one of them. So its outer electron is in an s orbital in an s sublevel, so it's in the S block. All of your group 2 elements, you would have sort of S2, whether it's 2s2, 3s2, 4s2. We wouldn't need to go any further, but you get the idea. So they've got 2 electrons in an s orbital in the S sublevel, so they are also in the S block. All of your elements in the D block will have D electrons, so D1, D2, D3, chromium's a special example, D5, D6, D7, so on and so forth. Yeah, so that is kind of where those classifications of the periodic table come from. So I've illustrated my answer with an example. I've given its electron configuration, and then I have explained why certain elements are classified as P block elements, their outer electrons in p orbitals, that should say within a p sublevel. That's me speaking and writing at the same time and doing a bad job of it. But yeah. Hopefully that makes sense, and you could answer a similar sort of question for any of the other blocks on the periodic table. If anyone has any questions, of course, please let me know in the comments or drop me an email, and I'm always more than happy to help. Hope you have a great day, guys. Thank you so much for watching. Bye!